I'm pleased to introduce Ron Bodkin and Dave Pickering from Glassbox. I met Ron a few years ago. We were both in the aspect-oriented programming community together, busily trying to make AOP something that was usable by the average developer. And we took a little bit different tacks, and I'm proud to say that Ron's is one of the first successful products that you can actually download and drop into your server without knowing very much about AOP. So I won't waste too many more of your seconds of your time. Here's Ron, and I'll let him tell you more about Glassbox.
Thanks, Nick, and thank you all for coming today. As Nick said, we're here to talk to you about Glassbox, which is an open source application troubleshooter for Java. So as you can see from this illustration of the web client that we use, Glassbox provides you a different way of looking at running Java applications to help you find problems. We'll look at an example of that later. So what Glassbox is doing is it really provides a kind of automated diagnosis. So it looks at what's going on in a running server, and it looks for problems in the application, suggests things that might be causes, and rules out things that are not indicated by what's going on. So it's got use throughout the development lifecycle. In development, it can save a lot of time troubleshooting, especially things that are not easy to isolate in a unit test, interactions, race conditions, threading issues. In the QA environment, it can be very good for, again, testing out integrations, things that might work incorrectly sometimes. It helps even in terms of isolating common requests, URLs, parameters that might cause issues, and in providing more actionable data so that when reporting an issue, you're not just stuck saying, well, something worked incorrectly, but providing some useful data. And as you roll out into an actual production environment, it also is designed to be low overhead and work well so that you can monitor applications and identify issues that happen to more quickly resolve, isolate the issue, and resolve them, reducing downtime. So some of the key features Glassbox offers are it's got a drop-in installation. So unlike many tools in this category, it's designed to be relatively easy to get it up and running in a new server, and it's easy to use. So you can have a web application that makes it easy clicking around to get data about what's going on. Glassbox has an out-of-the-box discovery capability, uses aspect-oriented programming and looks for common APIs so that it learns an application out and can provide useful data without any configuration. Of course, there's also more you can do if you do some amount of investment in configuration, but it doesn't require you to rewrite applications to monitor them, and we think that's a big advantage. And another big thing that Glassbox does is it provides a clear description of what's wrong with some supporting evidence so that you can take action. It comes with a notion of a service level agreement that's simple, that doesn't require a lot of configuration, that can be tailored. So that you basically say if a user request, if an operation takes more than a second, 5% of the time, that's slow. And there's a range of different exceptions of failures that are just problems and get reported as failures. So as I mentioned before, it's low overhead. It's designed to minimize the actual end-to-end response time overhead that it's required to capture the data. So there's some overhead on startup, but once the server is up and running, the overhead is quite low. We think it's less than 1% from our tests. Of course, you always want to test any system that claims to be low overhead. And it's designed to be easy to use and keep up as you evolve applications. So a lot of it is really the benefits of automation. What we see thus far is a lot of times when people are trying to find out what goes wrong in a system, they have two bad options. One bad option is to do a tremendous amount of manual work and to dig through capturing thread dumps or pouring through logs to try to figure out what's wrong. And then the other bad option is to not use tools, but to just do a lot of experimentation in code. And these are awful practices in the best case, and often chew up an immense amount of time, especially when, as is all too often the case, it's not clear whose fault it is that something's broken. And we'll talk more about that. So the automation angle, what Glassbox can do by automating is it helps at each phase of the development, right? In development, you're spending less time chasing down bugs, less time dealing with a high priority issue that you can't reproduce. In QA, it's easier to report something and make it actionable. And in operations, it's easier to identify what's wrong, right? And the list of benefits here is suspiciously similar to that on the last slide, so I won't go through that again. So the summary is most organizations spend a lot of time monitoring their applications of their infrastructure. But there's this challenge that they face. On the one hand, you see that there's a lot of ability to measure from a business standpoint things that aren't working well. Things that outages, blank pages, unacceptably slow response time. But the hard part is you take this data and then you say, well, what's causing it? We know that there's something wrong, but how do we drive it down to take action? So there's a traction problem. On the other side, technically, there's a lot of monitoring going on, and people have data about bugs and things that are trending badly, taking longer, disks filling up. But which of these issues is translating into actual technical problems that affect the user? So you get this gap where you have lots of data on both sides, but you have a hard time correlating it and putting it together. And the other angle on this, so one is technically being able to correlate, the other is just organizational. You can have a problem report and somebody's trying to identify, well, what's causing the problem. They escalate it up to operations and they can't reproduce it. Goes back to support, and then of course you have a conference call because nobody can figure out what's wrong. Well, you get a database administrator, or what do you call a person who administers a map-reduce system? I don't know what you call them, but maybe that would be a better term here at Google. So you get the data administrator, how about that, wakes up and they think, well, it's a code problem, of course. So there's a developer who's responsible, but they didn't write that piece of code, so they don't know what to do. Meanwhile, you've got an angrier customer, and you have another con call with more senior people yelling at each other and at all people involved. And of course, it's always amazing to me, on a normal day when you deal with an operations group, they're IMing 6 people, they've got pagers going off and they're talking on a cell phone, and that's just, things are normal. Then when, in this situation, things really get exciting and you get, managers yelling in both ears. Is it fixed yet? So finally, things have escalated to the point you get the guru who knows how to troubleshoot this thing off. They pour through they pull out their favorite whiz-bang tool, dig through piles of data, and finally, 12 hours later, and at unknown cost to the business, the problem is resolved, right? So this is a traditional way of resolving the problem. And of course, starting with everyone's favorite way of identifying problems in production, which is a customer phone call. We've talked to organizations where they measure problems by how many thousands of angry customers call in to indicate something isn't working well, right? So what Glassbox is trying to do is really work with an 80-20 rule. So we think that most of the common problems, most of the business impact from outages are caused by a relatively small number of relatively common things, and that it's worth optimizing to fix those first. Likewise, 80% of the people involved in identifying a problem can't deal with complex low-level tools. They may be very smart people, but they don't know this particular piece of technology or this particular system intimately to pour through a detailed dump of information from it. And 80% of the expense and difficulty in troubleshooting comes from handoffs, miscommunication, trying to get on the same page. It's hard enough when everyone is just operating normally, let alone when there's a crisis and things are not running well to do a good job. And of course, the other thing is most people are not the best troubleshooters under the best of times. There's this very bad human tendency, I've done it myself, I think all of us do, to jump to conclusions. You see a little bit of data and say, well, this is the issue, and then start pursuing evidence to support this hypothesis. And of course, that's a great way of wasting a lot of time if your guess is wrong, right? So instead, what Glassbox does is it automates some of the troubleshooting process and looking at a variety of different measurements. So it's important that the diagnosis be accessible to many, that it doesn't have to be a specialist, and that it produce an output that's clear enough that it can't be miscommunicated, so that people from different groups with different perspectives on the problem can agree on an objective fact and take action based on that. So with that, what I thought I'd do is I'd switch over and give you a demonstration of Glassbox in action. So I'm going to minimize this, and what I'm going to do is I'm going to start up a Tomcat application server on this machine, and I will take a few seconds. I have some slow starting applications on there to illustrate what's going on. So here we go. We've started up, and what I'm going to do is I'll go ahead and just pull up the home page of the server, and then we'll deploy Glassbox to the server. Let's see what I do. So let's see. Well, the server's up. That isn't an error page. So let's go ahead and take Glassbox is distributed as a web application, a WAR file. You can simply deploy it. Everyone's favorite way to deploy stuff for Tomcat, in spite of all those admin tools, is probably this. Copy files over to a web apps directory. So that's what I'll do. It's a little easier than clicking through an admin tool, and it's deploying. And then what you have with Glassbox is you have an installer. So you deploy the web application, and it guides you through an installation process. So we'll go ahead and, oh, I think I jumped the gun. It hasn't finished deploying yet. The disadvantage of demoing live things is you have to have a few stories as servers go ahead and do their thing. So we'll just wait a second while Tomcat does a deployment. And things always take longer when you're demonstrating them live, don't they? So of course, I know that Google's app server of choice is a customized version of an open source server. Is it based on Tomcat? Is that right? You'd have to kill me if you told me. OK. It's custom altogether?
I think I'd stop that and start it.
All right. That's bizarre. OK, of course, just when I stopped it, that's when it started. It responded. Let's, well, it's now deployed, so I can start up and just have it running. All right. Here we go. Deploying. Done. All right. All right, so here we are. Now we'll start up Glassbox, and you can see it pulls up. Can everyone see that, by the way? So there's an automated install page. It's identified that I'm running Tomcat with a Sun 1.5 VM. So I can just click through to install. I can generate a wrapper script that starts the server up with the extra VM arguments required to have Glassbox watch what's going on. So here I'll just pick, for convenience, I'll pick the script that I use to run it from the desktop and say I want to wrap that. And then I select, and it's finished. So I will minimize this. And then what I can do is I can just stop the server and double-click the newly generated wrapper script to start the server up again. And now what I'm doing is I'm starting up the server, having deployed a monitor jar and load time weaving with AspectJ. So basically, it's added some VM arguments so that Glassbox can see what's going on the server as it's running. And that allows me to get more visibility into what's going on in the application. So it's starting up the server right now and deploying or running and then redeploying some applications. And what we'll do is, as soon as it comes up, so it's now displaying the build, I'm going to click. We have an automated verification tool to make sure that everything's running. So it's up and running. I click verify. Everything is running correctly. And now I can click to the web client. So the normal way that people look at data inside of Glassbox is through an Ajax web client. You can see here on the top. Hopefully you can read the font. It's a little hard to read probably from the back of the room. But it lists the different business operations that it's observed. So at this point, it's monitoring itself. The application is a Glassbox web client. And it gives some data about average times and executions. Thus far, there's nothing terribly interesting going on because the system is running normally. So Glassbox says, well, everything's OK. So what I've got here for you is a couple of example applications to illustrate monitoring code that we didn't write. The first one is everyone's favorite is a pet store. So we've got the Ibatis Pet Store, open source example application written with struts. And we've added a couple of things in that don't work quite as well. We didn't change the application at all to make it monitored by Glassbox. It's the same standard code. We just added a few common programming issues to illustrate how Glassbox can help you when you run into these in real code. So here, we're browsing through the pet store. We're looking at fish. And I click on this one, and it's taking a while. And then it listed it. And if I come back over here to the Glassbox web client, it refreshes. And you can see here it said, well, that's a slow request. It was slow in the database. And if I click on it, I can see an analysis below. I can also open it in a new window by hitting Control-click. And you can see here, it's analyzed. This is a slow operation because of the database. And it gives me some basic information. It took 2.5 seconds. And it's identified a specific prepared statement that was slow. This prepared statement was slow on a database at this URL. So now I've looked at, and again, this is all without modifying the application. It just watches things like JDBC calls and is able to correlate them. I can scroll down and get more data. So as you go from the higher level overview of what's happening into more details for the people who are responsible for a specific component. So looking inside the database, the slowness, it gives me the prepared statements that exceeded my threshold. Again, I have it configured with the default if something takes 1 second, 5% of the time it's slow. This query took 2 seconds, so it was too slow. And it also told me which prepared statement parameters were slow in the slowest cases. Oftentimes what you'll find is things are occasionally slow under certain data sets, so it's important to know when they're slow to make it easier to isolate the issue. It also will be able to, it also tracks what's going on in the server so that it can give a thread snapshot of what the server is doing. In this case, it's telling me that it's blocked on a socket read. I can expand it out and get a stack trace if I want to see exactly where in the code is that slow query coming from. You can see here, that's the line of code. It's in a run cache query method on line 78. I can collapse that too. And then the last thing that it's presenting as useful information is it gives me an exact URL that was used to hit the slow behavior. And if I had post parameters, it would list the post parameters as well. Again, making it easy to reproduce and track down what the issue is. Provides some, and then below, the web client provides some common solutions for slow database calls and outlines things that it ruled out. So that's an example of how Glassbox analyzes and presents clear indication of what's going on when something is working incorrectly. I'll show you a couple more examples in the pet store application. So our lizard link is notoriously unreliable, and when I click on it, I get an unfortunate error page, not a very well crafted one even. And if I go back over here to the web client, you'll see now a red line indicating that this operation actually failed. I can expand that, and it tells me it had failures connecting to a database, and it gives me the database connection name, what URL it was. And similarly, it gives me a stack trace and SQL state and error codes that tell me what exact issues happened on connecting to the database. So it makes it easy to, again, troubleshoot, and I can see which URLs are causing it to fail. So that's a second example. And then one more example from the pet store of another thing that we can detect is I'll go ahead and I'll pull up a saved order. It asks me to log in. So here's an order. This is normal, but they added a whiz-bang feature, view with web service. And when I click on that, you can see that the thing is a little bit slow. Turns out that we added in a common problem, which is chatty web services. So if I come back over here, it's identified that there's a slow remote call. I can click on it, and it's identified a URL of an endpoint that was slow. And just like with databases, it indicated which requests were slow, and in this case, there were no parameters. But it again, provides more data to help narrow down the issue. So that's a few examples. I mean, it also looks at thread contention for things contending for locks. And if you wanted to see me run a load test on the system, I could illustrate that problem for you as well. The last thing it's worth looking at is we took the open source to-do application, which isn't much of an application, but it's about the best open source Ajax application that's out there, which I guess says something about how much easier it is to talk about something than it is to actually roll out code for it. So here we are. This is to-do lists, and it's a beautiful Ajax app that lets you manage to-do lists, misspelled for some reason. So you can see here I can do beautiful things like click edit, and it pops out a inline thing. I could cancel it. I can change, all of the nice Ajax things you might want to do. It's got old school monitoring built in with the kind of thing that we don't think people want to deal with. It's kind of a long list of monitors with lots and lots of data to wade through, but not telling you much. So that's certainly not the way we like to monitor things. But then over here, when I look in the Glassbox web client, I can see that in fact, I think everything managed to run under the threshold, so I'm not seeing a lot of slowness. You would hope that an Ajax app that is only managing to-do lists wouldn't exceed a second, and it barely cleared it. It had 800 millisecond as the slowest one. But what you can see that's interesting is it has in here a number of different operations that are coming from the DWR framework, which is an Ajax framework for Java that does remoting. It lets you marshal requests from JavaScript into Java and then return results seamlessly. So it's identifying those Ajax requests from DWR as operations, and it can look at things like database access and so on to diagnose those. So we've started to implement some Ajax support with DWR and think that there's a lot of opportunity there because we're pretty confident that from past history that people will find ways of writing slow, chatty Ajax apps that are inefficient, and it's an important area to diagnose. So that's a little demonstration of how Glassbox works. Any questions so far? So far, so good. Question, yeah?
How do you set your threshold parameters?
So how do we set the threshold? At this stage, we have a global threshold, and there's a properties file you can edit that you specify two things. What's the time threshold for something to be slow, and what percentage of time does it need to exceed it? A natural next step would be to allow you to configure things in groups or by packages, so you could have more fine-grained configuration. That's something that we're probably going to do relatively soon. There are other options. Something we'd like to do later on would be having more of a training mode where you could run the system once under sort of normal load and say, the system responded like I'd expect here, and then if it deviates, tell me in future. So but at this stage, it's a global one and looking to drill down into having more configuration on individual operations. Yes?
How do you detect what database is slow that needs to be configured?
So we don't, the question is, how do we detect what database is slow? And you don't configure it. You don't have to change Glassbox. Instead, what we're doing is we're instrumenting the application using aspect-oriented programming. So we use load time weaving. As classes get loaded in, we see, OK, this application is making a web service call, or it's accessing a database. And we correlate the different calls so that we're able to determine what prepared statements run, what database you're connecting to, et cetera, non-invasively. So let's.
Can you get a little bit stronger? You don't need to recompile. You don't need to bake us in. Drop us in on top of your already existing app, and everything's cool.
Right. So Dave wants me to reemphasize that you don't need to make infrastructure changes to recompile, to put Glassbox in, or to add API calls into the application or to reconfigure. So it's very much designed to be something that you can deploy it with an existing app and get useful data. And you can put additional investment in if it's adding value for you to get more out. But out of the box, you can get the kind of results that I showed you here, where you were able to see common problems like slow database, misconfigured systems, and get useful information to troubleshoot those. Yes?
How do you store all these instances of problematic situations? Because I guess if you run, for example, an application that runs in production and the customer hits it, or various customers actually hit it like a few hundred times a second, and every time the database is slow, you will kind of quickly get a very large number of these kind of problems. How to save them?
So the question is, how do we save the data? So Glassbox is rolling up aggregated statistics. So it's not saving a transaction trace for each request, because that would become an overwhelming amount of data. So the way the thresholds work is, if something is slow once in a blue moon, we're not going to flag that as necessarily an issue. You could certainly change it to like 0.001% of the time slow is too slow, and then we'd flag it if it were ever slow. But we save data about the things that are exceptions. So if there's a failure or a slow behavior, we're going to save some data about that. But if there are tens of thousands of normal requests that go through, we don't save data about it because they're not the focus. You're not trying to troubleshoot those.
I understand that you don't save kind of normal requests, but still, the number of these kind of errors may probably grow.
Right. So we have a limit. We keep like the last 5 failures. We don't keep thousands and thousands of them. Again, for the same reason that we want to help you narrow it down. If you're running into a situation where something is happening thousands of times and say an exception is happening, then I would submit either you've got a lot of problems or else that's not really an error in your application. It's relatively easy to tweak it. We haven't run into a lot of cases where people have said, okay, the system is identifying thousands of errors here. But there are you certainly could, if you really cared about just this one error, I think the right way to handle that would be more of a user level trace. We've talked about that. It's not too hard to implement with what we've got now, where you could basically turn on a bit in the session and say, watch this request and report on it separate from the others. So if you wanted to identify a very specific problem, that's how I would evolve the technology to go after it. I mean, and there's another part of your question that also is, in a clustered environment, how can you look at what's going on? And Glassbox does have a way of configuring connections and saving them so that you can aggregate data across a cluster. On a single machine, it's not very interesting, but I can show you an example. I can pick between JMX or direct RMI, and I can connect again to the same server, this time using a remote connection instead of a local connection, and it will present data for me about both of those connections. So I'll clear that and refresh, and it should pull that up. Oh, my IP address has probably changed because I'm jumping around networks. RMI is really awful at dealing with changing networks. But of course, that's probably not the biggest emphasis when you have servers. So I could restart it or turn off my network connection. Anyway, but so in a connected mode, you can use that to configure these different connections, hopefully to different servers, so that you can aggregate data across a cluster for what's going on. Yes?
The applications that you're monitoring, do they have to be J2EE applications? Like, do they have to be servlets, JSP, et cetera?
So the question is, do the applications we're monitoring have to be J2EE, specifically servlets and JSPs? So we monitor a number of different APIs. Some of them are J2EE, now Java EE APIs. Some of them are popular open source standards, like struts, or Ajax WS is a J2EE standard. So any of those different APIs that we already understand out of the box, if you've implemented them, we'll recognize them, JDBC, et cetera. Now, if you have your own custom API, I'll show you how it's relatively easy to extend Glassbox to understand your framework, your dispatcher patterns, et cetera, without having to instrument code everywhere. So you can define fairly succinctly, this is what it means to be an operation or a remote call, et cetera, and then any applications that's following that framework also are able to fit into the Glassbox analysis framework. Yes?
You mentioned sessions before, so it raised to me the question of, do you have any way of keeping session or context or history, something where you can say, okay, here's this problem, and it happens when this sequence of operations occur, or something where you get not just a call stack for a specific operation, but more like a session stack or something like that.
So the question is, do we have a way of keeping track of session history to identify what's the full session that produces the problem? And that's certainly a good feature request, and one that we've thought about. We currently let you say, here's the state of the request that generated this issue. But a natural next step would say, okay, let me look at a series of interactions, a session state, et cetera, that led to this. Relatively easy for us to do. There's also, though, the tension that it's easy to aggregate more and more data and throw it at somebody. So we don't want to overwhelm someone with details that might be relevant. We really think part of it is we want to make it easy for somebody to see what's happening immediately. At the same time, there's certainly value in making accessible information that we can easily track, so you can investigate. If we take you this far and you want to see, well, one more thing, that it's available. So it's a great feature idea. So one of the questions that often comes up in any system like this is, what's the performance impact? And what we've found is that there's very low overhead at runtime, so that we think it's quite suitable for production use, and we have some customers, organizations that are using the technology that are testing it with the plan of putting it in production. Typically what we'll see is the end-to-end response time increase is about 1%. And the reason why is because we're much more selective in gathering data. So systems that want to instrument every method that executes and build up detailed data structures to provide profiler-like data have a hard time achieving the often quoted 5% overhead number. In our case, we're really not doing heavy instrumentation. And we see when you want to dig deeper that it's more sensible to use a spotlighting approach instead of gathering data across everything. And when we do want to look across many different operations and look what else might be slow, we use thread sampling. So on a Java 5 VM, every 100 milliseconds, Glassbox will look at a thread that's running a user request and say, well, what's it doing? And that lets us identify other places in the code that we didn't anticipate that might be slow without putting a lot of overhead in. The one place that we do have noticeable performance impact is really on startup. So we use AspectJ load time weaving, and our measurements say that it's about 50% slower for class loading for initialization. So as bytes get loaded in when you're starting a server, that's noticeable. And then there's about a 20% overall memory increase. Typically, it's data that's used when you're loading classes. So once a server is started up, that is no longer in the working set and can be paged out to virtual memory. So unless you are running up against the virtual memory limit on the machine, it probably won't have a performance impact. But those are the main areas where we do see performance impact. So, the Glassbox is now all open source. Glassbox 2.0 is now in beta, and it really brings together the AOP approach to gathering data with using JMX and other to gather especially VM level data, and then provides it to an analysis engine that runs inside of the web application so that it can correlate and produce summary findings. Again, with a focus on identifying common issues so that you can easily resolve them. And as we continue to advance, we keep looking at, well, what are additional issues? What are additional things that we can help with? It's under an LGPL license. It supports Java 1.3, although Java 1.3 testing is pretty limited, so 1.4 is recommended. I'm guessing you're probably using Java 5 anyway, right? So the slide is actually out. We already are in beta. It's early September. Yeah?
You mentioned in the database the death by 1,000 cuts issue. I would imagine that's just too many calls to the database, and each one takes a little time.
Good guess. So yeah, the question is, well, what is death by 1,000 cuts? Death by 1,000 cuts occurs in almost any kind of a remote resource. The tendency to make an excessive number of requests, each one of which is relatively quick, but they add up. And this is a common anti-pattern with database. People are using OR mapping tools, will often find themselves inadvertently stumbling into this. Say they map a collection that gets loaded lazily, and as they iterate over, each request for a new row generates a database request. It's a popular way of slowing down a system with web services. You write a lot of fine-grained web services calls. It's going to be a popular way of slowing down an Ajax application to make lots of fine-grained requests for data and treat it as if it's a local call. Yeah.
So I'd be interested in seeing how you show a case of that's of interest.
Okay. I'm trying to think if our example makes it easy. I mean, we've definitely. If I ran the load testing tool, maybe afterwards I'll try to pull one up for you. I don't want to try to do it while we're videotaping and everyone's here during the talk, but I could show you an example afterwards, definitely. I mean, the summary is it shows you a list of the ones that have notable time, so you can see all of the different ones that run with the request that caused it. And that gives you a pretty good trace for what's the sum total of things that are happening to help you reason about which of these things need to be changed. Death by 1,000 cuts is one of the harder problems to fix because there's usually not a quick fix. You can't go in and add an index to solve death by 1,000 cuts. You need to rethink the design of the operation, but at least we can help you identify what queries are causing the problem or other statements. So some of the things that Glassbox won't do. Maybe I should just go to full projection mode here. It won't solve problems that haven't happened yet. So it doesn't try to anticipate future problems. It's more going to report the things that have already occurred. We don't claim that we're going to diagnose automatically every problem. Instead, we're really trying to focus on the common ones, the ones that cause the most problem. That being said, certainly we think whenever there's a problem, we'd like to give as much useful data to start with as we can. So we'll tell you as much as we do know to help diagnose it, and for the ones that are really common and that we understand well, we can really make it dramatically simpler. We're not trying to be a tool for all people. We don't want to become another data viewing, crunching, number crunching tool. We think that there's room to integrate with monitoring tools and analysis tools to provide good output, but we want to be more focused on the initial troubleshooting. And it's not workflow automation. So, and talking about 80-20 common problems and how we can solve those, when we started the project, we spent a lot of time looking at examples of things that had failed from our own experience, talking to others who'd spent a lot of time running and debugging large-scale server applications, and we categorized them like this. So we looked at things like hardware problems, configuration problems, application server problems, et cetera, and tried to organize them and say, what are the most popular things that people do that cause applications to break? And then, what can we do to automate tests to simplify fixing those? So this fishbone diagram, as it's called, illustrates some of the ones that we've run into. And one other thing that's worth noting, in addition to providing the web client, there's also, you can use JMX Remote to access Glassbox data. So the JMX management API for Java allows you to make remote connections in, and you can connect into a running server running Glassbox and get data out. So I'll show you a quick example of that here. We've got the server running, and I'll just pull up a JConsole, which is a tool that comes with Java 5 that lets you connect to remote servers and look at JMX data. And you can see here that there's an additional topic here. So Tomcat has lots of JMX data built in. Glassbox also exposes a statistics tree, so you can see here organized by, at the top level, application. I can see the various different operations that the to-do application has, or I can look in the pet store and see a nested tree inside of action servlet. And we filtered out to pick the actual struts actions as the things that are interesting. So I could look it down here at view order action and see database access, and you can see all of the different pieces of database access that we monitored that weren't terribly interesting, so we didn't identify them, call them out, but we were watching, and you can get more detail through the JMX JConsole if you want to dig in and look at, see, well, what exactly happened here. So it does expose low-level data in this format as a way of providing additional information when needed. But we also don't think that this is a great UI for overview and monitoring and top-level troubleshooting. It's a good resource to dig into if you need to. So another question that we talked about briefly is, how can I extend Glassbox to understand better an application that's not using maybe all the APIs that Glassbox currently understands? I mean, it's designed to have a very good plug-in architecture, so it's easy to extend, to add support for new types, to plug them into that infrastructure. And some of that comes from AspectJ's load time weaving support. So you write something about this piece of XML that says, I'd like to extend my notion of an operation to be anything that's inside of the com.myco.service package or its subpackages. Then any types in that package, the operations inside of it will be considered to be reported on as operations by Glassbox. So it'll show up as an operation. So it could be as simple as writing that much XML or writing a small amount of code that extends the library and then deploying it alongside of the standard Glassbox library. So you might build another jar or deploy this XML fragment in a classes directory or inside of a web application in order to get additional data. So it's designed to be extensible. The overall architecture is that inside of your JVM, we're using load time weaving in JMX to gather data. So we have a monitor jar that captures that data all around any applications running. And then that gets put into the web application that does analysis on it and exposes it both through a JMX remote interface and through an Ajax web application. And that lets us, of course, monitor the interactions with back-end web services and databases. And a lot of this is based on the fact that Java is used as a hub for integrating data across a lot of different services. One thing that we currently don't do is we don't look at what's going on in front of the app server. So if you have issues running on Apache or a load balancer in front, we're not currently set up to gather data and analyze those, although that's obviously a good direction to move in the future. So one of the things that underlies the analysis is the notion that at the end of the day, you've got really 4 kinds of problems, right, at a high enough level. You can have components and resources, and you can run out of components because you use too many of them or there weren't enough to begin with. And you can have components that just fail or that consume too many resources. And ultimately, troubleshooting is all about taking these abstract categories and drilling them down. So as we continue to develop Glassbox, more and more we want to make it easy to define the components and resources. So have out-of-the-box definitions like we've already supplied, but make it easy for you to plug in to the analysis framework so that you can drill down in what components matter in your organization so that you have the right way of people looking at issues. So, the use of aspect-oriented programming enables this kind of very non-invasive monitoring, so you don't have to maintain changes throughout a code base. You don't have to rewrite a code base to gather application monitoring data. And that makes it easy to update. It lets you selectively apply monitoring in the right areas. And it leverages the advantages of a popular open source tool, AspectJ. So, it's not the Glassbox project that wrote instrumentation code that you have to trust, but it's a project that's been around for 10 years now, 5 years since the 1.1 release that's the basis of the load time weaving engine. So there's a lot of experience and many different organizations committing to the load time weaving support of AspectJ. And we think that that's a real advantage as well as, and of course the other thing that hopefully you've seen so far is you don't have to dive in with both feet to AOP to get benefits from the technology. You can use it, you can deploy it to a system, you can make small additions to it and learn a little bit about AOP, but don't need to rewrite your applications in order to use it. So, and this is another example of if you wanted to go in more of a code style instead of an XML style, how you might write an extension to Glassbox to monitor something. So who here is familiar with AspectJ? So I won't try to explain all of AspectJ and its syntax to everyone here. But the basic point is that what we're doing is we're saying, here we want to pick out a type, mail transport, and execution of methods inside of that type. And that will let us monitor access to those as a remote resource. So with a very small, compact piece of code like this, we can compile it, distribute it in a jar, and then extend Glassbox to monitor email. And then from a framework standpoint, the code that supports it is listed here. We have an abstract reusable aspect, a reusable type that you can extend, and it uses a response factory API that's flexible to make it easy to plug in different implementations, with Spring AOP, even with manual instrumentation if need be, as well as with AspectJ. So with that, I thought I'd finish with a few minutes of just discussion of features and ideas for things that you might, that we might do going forward and get some input from you. So before I dive into that, I'd like to see if there's any more questions from that first section. Yeah.
So if you didn't want to use Glassbox in a web application, is there just like a jar that you can kind of point to in the class path and have it monitor something else and just use the JMX interface?
So yeah, you can use Glassbox. The question is, could you use it in something other than a web application? Can you just use a jar? And yes, you can use the Glassbox monitor jar. If you have that and the AspectJ Weaver jar on your class path with the proper VM arguments, you can gather data about what's happening in your running application. Normally in those situations, you're going to want to write some kind of a monitor to say, here's my unit of work, because it won't be any of the web model view of controller frameworks that we know about. And you can certainly get JMX data, but you also, if you run it in that mode, you might want to still run Tomcat and connect out remotely to that running app through JMX to give you more analyzed data. So you can run it. It's a little bit of configuration to do it, but it's not hard. So that's definitely a good way of running the app. And we've already had people running Glassbox in that style as well. Yeah.
I'd like you to test your memory and name all the things that are monitored. Because I think some of them weren't, we lost a slide or something and we missed, I think some of the things that we troubleshoot weren't on there.
Right. Well, maybe the easiest way, instead of testing my memory, is I can show you the list of things that we rule out as a way of providing an overview, right? So we look at, in addition to database connections, database calls, we look at threads that are running to find contention, where you get synchronization that slows the system down because things are locking each other up. Failures, as well as slowness in web services, EJBs, and other remote calls. Things that use too much CPU. error pages and exceptions in Java processing, database calls being slow as well as failing, and time spent in the dispatch layer. So those are some of the different things that we monitor and rule out. All right. Let's look at some of the things that we think are also important going forward. So one of the things is most organizations have invested a lot in having a good systems monitoring infrastructure, and we really see Glassbox as providing analysis and application specific logic to do a much better job of analyzing what's going on inside the app. So we think that there's a lot of value in integrating Glassbox into systems monitoring and doing a little bit to extend it to do even more to monitor your applications. So that's an area that's exciting. Another scenario that actually came up earlier is this notion of filtering by user or by customer, where if somebody has an issue, they report it, you could set a trigger, say in their session, and when they run an operation again, you get specific data about what's going on for that session, for that user. So it can really let you isolate an issue. And in a system with many users running at once in production, we think that's a very valuable way of slicing and seeing what's going on for a specific problem. Another thing that we see a lot of potential around is having more component owner focused reports. So what's an analysis of what's going on from a database standpoint? I own this part of the application. I want to understand how my stuff is working. Sometimes even just understanding which pieces of the puzzle are involved. So thus far, this request used these 4 components and not these 3. All of these things help with the goal of narrowing down who should be looking at this problem and providing data for them. So different user-focused reports we think is important. Training, so the idea that you can start the system up and run it with a test load or run it under a certain mode and say, this is good normal behavior, or this is good normal behavior, but this, and this is unacceptable. And so instead of having to configure everything, you can train it that way. Another way is, of course, just letting somebody look at reports of the data and say, well, this is actually too slow, or this is acceptable, and letting people interactively configure it. One of the big things, though, the reason we started with a global threshold was we think that the worst thing you can do is require people to go in and configure a million things. That we want to start off with something simple and with useful defaults, and then if you need to extend it a little bit, you can. Another thing that we often have requested, of course, is more historical views. And our philosophy on that is that we like to have a kind of a telescoping view of history. So you have data about the last 5 minutes, but then you have summarized data about the last hour, the last day, the last week. And a lot of times what we believe is the best predictor of what ought to be happening is what happened a week ago, because things tend to be cyclic in the business world predominantly on a weekly basis. So Monday morning should look a lot like last Monday morning, but probably nothing like yesterday Sunday morning. And likewise, very useful to do things like baseline. Okay, I'm about to do some significant event like pushing out a major release or integrating a new component or upgrading. So I like to compare how things have changed between baselines. And then there's lots of interesting things when you move into scenarios where you're not running an interactive application, where you've got back-end processing of message queues or services. And really, we think one of the things there is that there's different service level agreements than response to single requests that matter. And we've been talking with different organizations with requirements there. Throughput becomes an important issue in some cases. Fairness, time to go through all the hops and get an end result to a user. So we think there's interesting things to do to enhance monitoring and reporting on and end-to-end processing. And then, of course, there's lots of different technologies that would be good to add more monitoring for. So more monitoring of Ajax frameworks is high on the list. There's a lot of web frameworks, and it's relatively easy to extend them. More monitoring of caching, more monitoring of JNDI and OR mapping. So there's lots of additional pieces to monitor. And certainly one of the things that we've designed is to make it easy to extend the system so that anyone who has a need for one of these could make a contribution back and share it with the community, so that we're not writing and debugging monitors for every framework in the world, but it becomes very easy for the community to contribute and maintain its own set. And we talked about briefly being able to reach out and have more data about system health. We think that's going to be important going forward with Glassbox as well. doing more with clustering. At this point, we're doing client-side aggregation with a little bit of configuration. We think there's more we can do. Another thing that we're working on now is email alerts. So when things pass the threshold, you can get an email out and say that something went awry. I think that's a valuable thing. And then lots of different analysis slices. So there's lots you can do, ranging from rules to statistical analysis. Our philosophy on the different analysis techniques is to take a look at specific problems and say, what's the simplest way that we can reliably predict this thing? And a lot of the value in the analysis is also, it's really important that it not be some strange oracle that just tells you, here's the thing that happened, and you have no way of questioning or finding out. So it's important that if the system comes up with a conclusion, it's clear why, so you can trust it. So those are some of the future directions, and would love to hear from you, your thoughts about how this might be helpful. Any questions, comments? Yes.
So I'm curious if people have been looking at correlations between production behavior and their testing efforts, like in terms of the unit tests, etc. Has anybody been trying to merge any of this data?
So are people looking at correlation between how things behave in production and how things behave in test? I think that's a great example of something you could do with a baselining feature and say, what's deviating here? I'm not aware of it, but I think it's a great direction to move in. It's a classic problem, right? That things behave very nicely in test, but it's different in production. So what motivates it? Why is it different? What's salient? That's a great question to dig into. Yes?
So how much can you do on the memory leak analysis?
So how can we help diagnose memory leaks? So we haven't done a lot of work on memory leak detection, although there's certainly a number of techniques that you can do, and that we would welcome collaboration and opportunities to work with users on. It's not in the 2.0 release, but there are different techniques you can use. Detecting memory leaks in a Java application is I would say it's not a scientific process. It's a little bit of a black art, but to the extent we can automate and make it simpler, we want to do that. Yes?
When it detects errors or failure conditions or whatever, is it something that it just passively puts in a queue and then waits for somebody to call and say, give me a list of errors? Or is it like, does it have an interface where you can basically say, just notify me when you come across a new problem?
So the question is, when the errors or failures are encountered, does it wait for someone to pull the data, or can it push it out and alert you? So we're working on an email interface to allow you to push alerts out when something fails or shifts status from OK to not OK in some respect. We're close on that, and just configuring email and making sure you can do that correctly. So that's coming soon. So the current version, you go to the web page and you monitor it, but email alerts is coming.
So if you say you didn't want to run it in a web server, you just wanted to kind of log when something happened, you just spit it out into some text log, and you just at the end of the day look at all the exceptions that kind of popped up. That's something that would be possible after you do email alerts, or is that's completely separate?
That is separate. So the question is there a way of having an exceptions log? And it so happens there is a feature that's in the system that will generate a log of exceptions. So a request that's failing or exceeds the performance threshold, it can write it to a log. It's a logging topic you configure in your logging system. So if you wanted, you could tail that log and alert based on that. Any other questions? All right, well, we'll stay here if there's any more informal questions afterwards. Thanks a lot for your time. Enjoyed the chance to talk to you.